so now we're live. I won't typically record labs, but just since this one's we're learning Python, this might be a good reference, you know, set of videos. So let me share my PyCharm environment. And now we don't need to have the Anaconda window open. You don't need anything else. We can do all our development within PyCharm because we can just click play, right? So this is going to make us a lot more efficient than if we had to go back and forth between several windows. So can everyone see the screen? Can you read this text, or is it too small? Kyle seems to be on the fence there. I'll make it a little bit bigger. Let me see. Fonts here.
Sarah, how do you make yours gray? Mine's like white.
Oh, that is the, did that improve the, 20?
Do you mean like the whole window? Gray?
Yeah.
If you go to File, there should be like a settings, and then you can go to Appearance, and it's called like, it's like a dark mode.
Yeah.
It should be.
Dracula.
Thanks.
Yeah, good. It's really, you know, it's kind of a power move to have it in the dark mode. You know, people respect you. They say, wow. All right. So the nice thing about editing, so this is analogous to a MATLAB script, right? You are familiar with the difference between executing MATLAB at the carets, where when you hit enter it runs, and then creating a script file, doing it all up there, and then running it sort of like a program. So the same analogy exists in Python, and it's, you know, makes sense. They're both interpreted languages. All right, so go ahead and let's make a program that can print out the numbers 1 through 10. So it should say print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a comment in Python is a pound sign, a hashtag. Okay. So that will require us to use some arrays, some printing, and some looping. Okay. And our model of for loops will be very similar to MATLAB's model of for loops, not like C. So in C, remember, we had the I equals 0, I is less than something, I plus plus. In MATLAB, you were able to just step through items in an array. So you could say for x equals 1, 2, 3, 4, 5, and it would go through. Give me a thumbs up if MATLAB arrays, MATLAB for loops, like we got it. Okay. Now the Python syntax I prefer greatly to MATLAB. I think MATLAB syntax is a little, I don't know, clunky at some time. So in Python, what we could do is say for x in, and then we can just do the list right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and then in the for loop, we're going to put a colon here, and then we can just say print x. And the only thing I need to do to indicate that this is part of the for loop is to push print over a little bit to indent it. So in MATLAB, you had to put the keyword end at the bottom of a for loop, or in C, you had to use squiggly braces. In Python, we're just going to rely on white space. So the visual indent is actually quite important here. I have a lot of students that get casual with their indents and everything's lined up on the left margin, and that won't work in Python. You absolutely have to put it over to the right a little bit. So now when we press play, you should get it to run. Okay. Any problems? All right, now explicitly typing out this list is a bit of a hassle. There's some nice built-in functions in Python that we can use to create ranges of numbers, and in particular, we can try something like range 10. And if you hover over the name of the function, now unfortunately, let me see if I can change the way this is shared, and you can see the popovers. PyCharm. It's not doing popover. Hold your mouse over the word range, and you should see a whole list of help topics about this. Okay? Now, maybe this isn't exactly the easiest to read, but this is a great tool and one of the, again, advantages of using something like PyCharm versus like Notepad. Okay, so we can give it multiple parameters, and there's the default parameters for those that we're not going to specify. Okay. So notice that it starts at 0 and stop is omitted. So what do I expect this to print out? If I say range 10 here, that means all I'm providing is the stop. And this is going to step up starting from 0 and ending right before the value of stop. So this is actually going to give me what?
0 through 9.
Yeah. And, if you remember this, that's great. If you don't, just run it and say, oh, shoot, that's right. It goes 0 through 9. Okay. So if I want to actually include 10 in my list and start at 1, I should provide 1, 11 here. And then I get it, right? And so this is like MATLAB's start-stop step syntax. I could count by 2s here. 1, 3, 5, 7, 9. Okay, so my point here is not to make you experts at the range function. This is just one of many built-in things, and Google's your friend. I'm never going to require you to memorize anything. But this is how I recommend you start learning Python. Right? Go ahead.
Is it better to alter what's in the range function than to alter the x in the print?
I totally, equivalent. Yeah. Don't worry about it, right? So exactly. If you said range 10 and said, that's not right, let me just say print x plus 1. That's a lot easier for me. And maybe that makes more sense, right? My point here is run early and run often. After you type any code, try to run it, see what it does. If it doesn't do what you think it does, hover your mouse over some of the things to get the documentation, use Google, right? Developing Python should be kind of an interactive experience. It shouldn't be, let me type 50 lines of code, press play, and I guarantee you that, whatever happens won't be good. It's not going to work and you're going to be frustrated. Okay, so especially as you're learning the language and you're reading the book is going to make sense. You're going to read through this book like, dude, Python is for the birds, right? This is the easiest language ever. And then you're going to close the book and realize you don't know how to write a for loop, right? So make sure you type all of these examples by hand and then tweak them, change them. See if you can make them count by 2s rather than 1 at a time. Okay. For example, go ahead.
Professor, I'm getting an error on my screen when I try to run it.
Okay, so what does it say?
So it just says file, and then it has like the location of where my file is, and then it says syntax error.
Sure, so let me give my file a syntax error here. You see? So it says something like this?
Yeah, that's exactly what mine says.
Great. So it says invalid syntax. And, that comes from the rules of Python. It turns out you have to put a colon at the end of the for loop. See? And if we hover over the red squiggle, what does it say? You can't see it on mine because of the way the screen share works, but do you have a red squiggle? You should have a red line in your editor. Go ahead and everybody delete that colon if you put the colon on there. And you should see a red squiggle pop up in your editor.
Yeah, so it tells you that it's expecting a colon.
Yeah. And then so you put the colon in there.
Even when I run it, it's...
And then you should get a green check over in your editor saying no problems have been found. Are you having success now?
Yeah, thank you.
Yeah, great. Let's see, Rika, were you able to get it to work on yours? You can press play. Everybody sees the green squiggle there, or the green, I think the green check mark saying no problems found. Okay. Great. Why don't we change this loop a little bit and have the same behavior but use a while instead of a for? Okay, so remember with while loops, it's a question, it's a true-false condition. So while x is less than or equal to 10, print x. And already the editor's complaining at me, right? It's saying we've got some issues here. You can hit Control-Alt-L, and that will reformat your code according to Python's kind of best practices. And so that'll add spaces and fix things up for you. So if you see those gray tildes, those are style suggestions. You can ignore them. Red tildes means your code won't run. But if you'd like to get rid of the style suggestions as well, Control-Alt-L will auto format your code. So what's going on here? Why is x tilde red?
We never defined x.
Sure. So how should we do that? How should we fix this? If we never defined it, maybe we should define it, right? Now in Python, we don't have to declare the type of our variable. We just set it equal to something, and Python's smart enough to say, hey, you set it equal to a number, x must be a numeric type. So what should we set x equal to if we want to print the numbers 1 through 10? Let's see, I don't know. Davis, what do you think?
Sir, you said to declare it just like x equals 0 or x equals 1.
Well, yeah, so which should it be?
Oh, x equals 1.
Great. So x equals 1, and then all of a sudden my tildes go away. And if I run it now, what happens? Ah! This is a disaster, right? Why is it doing this?
You never set x to increase.
Yeah, I need to make it increase. So to stop this thing, I can just hover. I can click the stop sign. Okay. And then where do I need to add? At line 5 here? Let's see, Marco, what would you add on line 5?
So you have to add like x equals x plus 1, but you have to make sure that it's indented into the while.
Perfect. Yes. If I did this, what happens? Ah, right. I'm just looping around and around and around right here. Because print x is the only thing inside the loop. If I tab this over, stop it, and play it again, then, here we go.
So is that rule instead of having to type an end, like END?
Yes.
Like in C? Okay.
Yeah, so in C, white space is ignored entirely in C. You can have your entire C program, all 1,000 lines of code can actually be on one line of code. Anyway, why can C safely ignore white space? What does every line end with in C?
Is it a null?
Semicolon.
A semicolon.
Oh, sure.
Right? So the semicolon in C is used to indicate that I'm done with this statement. What follows is another statement. Okay? In C, how do I indicate blocks of code? Like the body of a for loop or the body of a function. I enclose it with what character?
Curly brackets.
Curly braces, right? So the designers of Python were like, man, all of that stuff is fine for computers, right? But humans, that's just annoying. Like ending every line with a semicolon is really a hassle when what you're really doing is ending every line with a carriage return, right? Hitting the enter key. So in Python, the enter key, like the carriage return, is essentially the semicolon. Okay? And similarly with the curly braces, the Python language designer is like, wow, nobody wants to exercise their pinky like that. Let's just go ahead and ignore those curly braces. And the best practice is to visually indent your blocks of code anyway. So we'll just rely on white space to indicate the box of our loop, right? And what if we had a conditional within here? Like, what if I only wanted to print the odd numbers? Right? So if I'm going through all the numbers 1 through 10, and I want to add an if statement here, say only if the number's odd, do I actually want to print it?
Can you put an if before the print, like if x is, I don't know how you would put odd, but not divisible by, I don't know.
How can we tell if x is...
Python have modulus, sir?
It has mod, yeah.
Yeah, so how do we do mod in Python?
Percentage sign.
And so do we remember the modulus? Who can tell me what mod means?
It's not like remainder, like if you divide it by 2 and the remainder is 0.
Yeah, and so what does that mean? If you divide by 2, if you can take the quantity of x and break it into groups of 2, and all the balls are accounted for, that means the number is what?
That's even.
It means it's even. Right? So in division, with integer division, think long division, like back to elementary school or, no, I don't know, middle school, whenever you did long division, that's integer division. Meaning that rather than having decimals, I'm actually going to have 2 values. I'm going to have the quotient and the remainder. Okay? And so when you do integer division with just the divide sign, you're only asking for the quotient and you lose the remainder. That's like in C. If you divide 2 ints, you just get the truncation. It doesn't do some clever rounding or anything, right? You just get the quotient. If you want the remainder, what's left over after you try to divide the thing into so many pieces, that's the modulus. Okay? So anyway, it's kind of a little bit of a trick. But the point here is not to, again, make you experts in one particular function or one particular math operation, but to show you some of the syntax here and also kind of how to debug things. So this worked, but let's say I got confused here. And I didn't do the right thing. And I'm getting odd numbers. Right? And so now I'm frustrated. And I don't quite know what's wrong with my program. So now what I can do is set breakpoints. So go ahead and just like MATLAB, you can double click the left margin and set a breakpoint. Okay? And when you set a breakpoint, your program will stop there and let you poke around and see things before continuing. And this is really invaluable when you start to write more complex programs. Now, if you just press play, it'll ignore the breakpoint. But if we press the little bug icon, which is to the right of play, it says debug. Then I'll stop right at this particular line. All right. And here, it's going to list all of the variables that are currently in scope, meaning like x is set to 1 right here. I have the ability to step around my code, and we'll talk more about these step tools after you get more complex code. But I can say resume, and this means play my program through till I hit the breakpoint again. And so go ahead and click that resume button, and you should see that you stop again at line 4, but now x is equal to 2. And even up in the editor, notice that there's an annotation up at line 2 now showing you the current value of x. So this is like a really nice program. Do you see how this debugger's working for us? Imagine if you had, tens of files and hundreds of lines of code, and you're stuck in some function and you just want to quickly see what the values are. You can see right annotated against your code, hey, the current value of x is 6 and such things, right? And then I can click on console here and then just play with some Python. So like, oh, x is 6. What is 6 mod 2? 0. Oh, so the modulus, I'm confused about the modulus, right? So I can play with some Python code now that I'm sitting here. And even better than that, I can actually manipulate the values of the variables in my code, right? So you see I just typed the word x there, or the variable x, and it gave me 6. Look at that. I can actually set x to a different value. So I can, within this debugger, now that I'm paused, actually change the state of my program and then resume execution. So imagine you're doing Battleship, and you'd really like to pretend like the aircraft carrier is sunk. Like, you want to get to that state, and you don't have to click all the buttons to guess all the spots. Maybe you pause your program and change the variables around, so all of a sudden the aircraft carrier is sunk, and then you resume your program and see what it looks like. Right? So this debugger is kind of like cheat mode. Does it make sense? All right, so, a lot of capability here. We're just scratching the surface because we don't really have complicated programs yet. But I want to show you, again, why we went through the hassle of setting up PyCharm. This should make it a lot easier for you as you type programs in and to run them and to explore. It's got to be interactive. I'm going to say this again and again until you just get tired of me saying it. Don't just read a book about Python. Write Python code and have it break and be frustrated and say, why is it broken? Use the debugger, pause it, see if the variables are what you expect. Change the code. Say, can I tweak it a little bit one way to the left or to the right, and run it again. And that's how you're going to learn this language. Okay, it's not a hard language. It's very similar to MATLAB, but the devil's in details about the colons and the white space and some of the other little syntax gotchas. Okay. So let me, any questions, I guess? All right, so rather than going on and on with small demos like this, let me point you again at the course textbook here. And so this is the website that has it for free. If you order it, then of course you'll have it as a paper copy. But if you don't have it, it's inventwithpython.com, 4th edition. I can put that into the chat here. Okay, and you're going to be responsible for everything up to chapter 9. Well, we're skipping chapters 1 and 2. We did that together because our development environment is a little different than the book suggests. Okay? These are complete programs, and each one is, maybe 50 lines long or so. He recommends you type them all by hand, and I think that is a good idea. But I understand you're sitting there like copy and paste works just as well. So that's fine too. But make sure you are exploring these programs. Like if you just copy and paste the code, try to change it somehow. Okay? And each one of these is meant to teach you some Python concepts. So if we go to guess the number, okay, you see he's got these topics covered in the chapter, right? And so don't get too excited about the quality of these games. They're pretty poor. But the purpose is to teach you something about Python and do it in a way that has a bit more of a story than here's how to use the import statement, blah, right? So I'm going to go ahead and give you the next... first of all, has anybody already gone through, has anybody here already looked at the textbook and gone through some of the chapters? A couple of us? Okay. Okay, great. Well, let me give you the next 20 minutes to work through wherever you are in the book. If you haven't started the book, start the book and start working through this, okay? I'll pick back up in 20 minutes and answer your questions. I want to try to get to functions today. That's going to be my goal, is to start talking about functions. So get started wherever you're at. Next 20 minutes is yours. I'm going to ignore you for that amount of time, but I will listen in. So if there is an issue, please just shout it out or use the chat, and I'm happy to answer. Right? Does this sound okay? All right. We'll get to work then, and we'll talk soon. And let's talk together. I started the recording again, so if you watch this later, there's a big pause there, but welcome back. And let's see, PyCharm. Let's get this window all synced up again. Okay, so we can write, what I kind of humorously call like naked code here. Just a line of a statement that when you execute this file, it will run it. That's considered rather poor form. It's much better to write your code in functions and then call those functions. Okay, so a function, you can consider it like a black box. Maybe you know what's in the box, maybe you don't. Maybe you wrote the function, right? Maybe somebody else did. But when you're using a function, you don't really care how it's written. You care about the inputs that it requires, and you care about the output that it produces. Some functions don't require any inputs. Some require a lot. Some functions don't produce any output, and some produce a lot. So, for example, print. What kind of function is that? Does that require any inputs? Raise your hand if you think no inputs required. You just say print. Okay, we've got... All right, so say, no, input, print requires some inputs. Raise your hand there. Can't call without inputs. All right. Well, let's try it. If I don't put any inputs in here, and I just say print. Oh, and let's go to chapter 2 now. Now that is going to run without error because by default it's just going to add a new line. Right? But I think the test question answer would be no, you should probably tell Python what you wanted to print. Okay, so all inputs to my functions are specified as a comma separated list in parentheses after the name of the function. So if print was a person, and I would say print, hey Bill, print something, hello world, right? And Bill would run off and do this, right? I have to give them the instruction on what do you want to print. Do you understand this idea of an input? So print requires an input. Formally, we'll call these parameters. So a function that requires parameters to execute, we call a function that needs some inputs. Okay? Now, when I tell Bill to run off and print something, I don't necessarily expect to get anything back from him, right? As long, I expect it worked, I suppose. You could say, hey, Bill, did it work? And he would say, yes, I got it to print. So there might be an error condition that you would expect to return. But in general, a function like print, we don't consider returning values. Okay? So print and so this is one input, no outputs. Okay? Right? What about something like the max of an array? Well, let me Let me give you a strict example the opposite way. X equals okay, so see this little 3-line program here? I called print twice, and I called this function called input. And I think if you've gone through the book at all, he uses this function a lot. So does input require parameters? No, there's nothing in those parentheses. Now I still put the parentheses there, and that indicates to Python that I am calling, I'm executing the function. If you don't put parentheses here, and you say x equals input, then you're creating an alias, like a nickname for that function. So then later you could call the input function by using the word x, which is very, odd to do, but we won't normally do that. Okay, so x equals input. What is this on the left here? This syntax here is how I capture the outputs of a function. Okay, so this function produces one output. I mean, it's funny, the name of the function is input, which is, of course it's asking for input from the user. The point is, again, imagine these functions are people, right? If it's Bill and I say, Bill, go get some input, I don't have to give him much more information than that, but I do expect Bill to return with this delicate little, string he grabbed from a user. Okay? Do we understand this idea of inputs and outputs? I mean, hopefully this is just a review. MATLAB makes it very explicit, the syntax of inputs and outputs. When you actually declare a function in MATLAB, you actually write it in that first line of the script file, putting the outputs on the left and the inputs in parentheses on the right. Okay? Other programming languages don't require you to set it up like that. But I do want you to understand the idea that a function is a box, and the box can take one or more inputs and produce one or more outputs. Okay? And I really don't care and really don't want to know, at least at this time, how input is actually written. Like, who wrote that? I don't know. Doesn't matter. All right, some functions do both. Some functions require inputs and produce outputs. Imagine I have another program and I'd like to know what the largest value in this list is. So there's a nice built-in tool for that. Max of my list. And there's two things I want to talk about in this short program here. And so let's first look at line 2. First of all, make sure it works. The biggest number is 10. Good. That should yes. Here is a function that takes an input and produces an output. Okay? So this is kind of both. We saw print, which is inputs, no outputs. Input, which is no inputs and one output. And then max, which is more typical, which requires some information in order to execute and then produces a result. And I would say this is the normal run-of-the-mill kind of function. Requires some information and produces some output. Okay, so do you understand how to use functions? Next thing we'll talk about is how to declare and define your own functions. But let's just make sure we understand what a function is and how to use them. Does this syntax make sense? Any questions? Okay.
So is there any difference between doing like the plus big num versus the %d % big num? Like, is there any reason to do one over the other?
Well, yeah. So this, I guess we can talk about line 3 here. I was gonna kind of put a pin in it and continue about functions, but just since you brought it up, try it out, right? So you could say the biggest number is, and then say plus big num. And what do you see? Right? So again, I really want to emphasize, try to break something, right? Margaret, that's a great point you brought up. Like, what happened if I said plus, right? Do it, right? It's so little friction to run a Python program. It's not like embed where you got to compile it and drag it over and open up TerraTerm and futz around, right? Just run it. And so what's the problem here? What's Python complaining about?
Big num is a integer, not a string, and the plus sign only works for strings.
Yeah, there's rules for two strings. How do you add those together? Well, you just kind of write out the first string and then start writing the second string. If a string is a bunch of letters kind of in a chain and a number is a number, it's not clear to Python what addition is. Okay, so you have a couple options. You could tell Python to interpret big num as a string. So convert big num into a string. And now big num, the first thing we'll do is call this function str, which takes in a single input and produces an output. Now here I'm not setting an equality, right? I'm not setting the result of this to a value. I could, right? I could say okay, and then I could put it string version of big num. You see? That's using the same syntax to bring it back to the function discussion. But this is a hassle, and I'm only using the variable in the particular context of sticking it in this function here. So what Python allows us to do is just to put the call to the function here, and what Python will do is run this function first, and replace this value with the result of the function call. Okay? Does that make sense? It's just a bit of a shortcut. So the way you should read this is the first thing that gets executed is str big num. That gets converted and replaced with the output. Sorry. Stupid phone. All right, one moment. I have this really old phone. It's sort of like a conversation starter. Like, wow, what an old phone. And then I get to go on and on about my view of mobile phones. But the problem is the touchscreen really doesn't work, so it takes a while for me to set it into do not disturb. All right. Yeah, so the other, and the kind of better way than using str here is to use string formatting. And so the string formatting rules are exactly the same as C and MATLAB. I mean, I know they're super weird, but at least everyone agrees on it, right? %d is somehow an integer. The only difference in Python is that we separate the parameters to the printf with a % and not a comma. Okay. If you would put a comma here, it would look like, oh, the first input to print is this thing, and the second input to print is this thing. And that's not what we want. We want to actually create a new string here. Okay, and so print, in C and in MATLAB, we have printf, which combines the formatting with the printing. In Python, we only have print. It doesn't have the capability to format anything. Okay? The way we format is with this % tool here. All right, and I think the book does a decent job of talking about formatted strings, so I won't belabor the point. But it is a difference from the languages you might be used to. That, yeah.
Suppose you wanted to put two variables in that same line. Could you do a second %d and do like a comma?
Yeah, so that's
or something like that?
Good question, right? So maybe the biggest number is this, and the first is %d, right?
Yeah.
Now, look, I've got a warning. Right, and what does that warning say? Too few arguments for the format string. PyCharm is smart enough to realize that there's 2 %ds here and only one thing here. Now the syntax for specifying multiple kind of insertion values is to actually provide it as a list. Okay, and so I'm going to put them in parentheses here and say my list 0. Okay. And you see that's going to be the syntax we'll use. So you put percent and then you put parentheses around it and then comma separate it with that. Okay. There's a slight difference between using parentheses and using brackets, and you really don't need to worry about it. They're called tuples versus lists. I think the book probably talks about it, but tuples are a little bit faster. So when you don't need the ability to add or change things in the list, putting parentheses makes your code run a little bit faster. So this is just a list, okay? And then the first item in the list goes to the first thing here. The second item in the list goes to the second thing here. Okay? All right, so we got waylaid, but I think it's fine about string formatting. I want to get back to functions. Can we do that? All right. So I want to write my own function. What should my function do? My function should tell me whether a number is prime or not. It's one of my favorites. Okay. So I can say, wouldn't it be great if I ask the user for a number, so pretend you already have the function is prime. Say that exists. It doesn't, but say it does. And we'll go ahead and write the code to prompt the user for input and call this made up function and display the result. All right, so is prime is going to return true or false. So try that out just for 2 seconds. Or not 2 seconds, 2 minutes. I don't know. Something that's appropriate.
Sir, when we're running like a new script,
Yep.
or a new file, do you have to change the it says like chapter 2 up in the top right hand corner?
Yeah.
You have to actually change that every time you make like a new script.
Right. So if you want to execute a different Python file, when you click play, you just go up to the top here, and I'm going to do the desktop share. There we go. And you're going to say edit configurations, and then you can add a new configuration. You see that? And so you can add a configuration for each one of your Python files. And that way you just have a drop-down box of chapter 1, chapter 3, chapter 4, chapter 5, or whatever. You could go back and just edit the single configuration, but then switching between two back and forth is a real hassle. Created a bookmark somehow. I'll have to delete that. Okay, so print welcome to prime checker, right? I don't know. Enter your number. Sure. Yeah? Like that? Make sense? And then we would say if num is prime, or sorry, if is prime num, print maybe we'll be fancy, right? Okay, what do we think? This is gonna be a pretty awesome program. People are gonna make money on this. App Store, here we come, right? This got a half smile out of Brooklyn. There we go. So, of course, if I try to run this, I've got an unresolved reference to is prime. But notice, and I'm just gonna point this out again. In interpreted language, you won't hit problems until you actually get to that line of code. Unlike C, where C won't even start to run until the whole program compiles, right? But look, I'm ready to input my number. My program looks fine here. You see that? Why am I able to execute Python right away? In C, I have to wait until absolutely every line is syntactically correct. Maria, what do you think?
Is it because it's an interpreted language?
Yes, right? So that's the vocab word, but if you were to explain to somebody that was new to the class without using a buzzword, how would you explain what's going on here?
The code will run until it reaches a point where it doesn't make logical sense, and then it'll give you an error message.
Yeah, so in a compiled language, there's a compiler, another program that goes through your whole thing and creates a bunch of ones and zeros, and that is the program, and then that thing runs, okay? So unless the compiler can execute successfully, you won't get those ones and zeros, you'll never start your program. In an interpreted language, it's a while loop, right? It says, hey, let me get the line of code, let me run that code, now let me get the next line of code, let me run that code, and it'll just kind of march through just like you're reading a book, and only until it hits some bad line. And then it'll give you a problem, okay? Now, PyCharm is helping us out here by letting us have a bit of the best of both worlds. Python can be very frustrating because of this feature, and that you can type this whole thing, have your code run, and unless you actually hit the bad line, you won't realize you have a problem in your code. So maybe your bad line is deep in some if statement, like only in the case where the ship is in a super mode, and there's 10 bad guys in the field. That's when you get to line 86, and that's where your problem is. And so then all your users who happen to, find themselves in this situation tell you your game is buggy, and you're like, well, when I tested it, it seems fine, right? So that's one problem with interpreted languages, is that you don't have a compiler to check your work. So PyCharm is going to go through and try to run everything in the background, and if it has a problem, it will put a tilde under it for you. Okay, so just because there's a red exclamation mark at the top doesn't mean your code won't run. It means that PyCharm has gone through and figured out there is a chance, depending on where your code actually gets to, that there will be a problem. You see, it's a bit of a subtle difference here, but I think it's an important one to continue to make. Okay, so fine, I can enter a number here, and only after I enter this number, 45, that's when I get a problem. Okay, and the problem is a name error, that this is prime is not defined. I need to define it. Okay, so I needed to define it before I use it. So why don't I go ahead and define it maybe at the top of my code here. Okay, so to define a function in Python, use def, define, right, is prime. And then I can specify the parameters I expect okay, and then the body of the function has to be indented. And let's just, I could go through here and ask you how to find a prime number, and I will, so don't worry. But for now, let's I stub this out. Again, my mantra here is run early and run often. I don't want to sit here and write 10 lines of prime checking code and then press play and hope that it's going to work. Okay. How can I try to stub this code out so that I can run my program without errors, even if the prime thing isn't done yet? What's the shortest amount of code I can put in this function in order to have the code syntactically correct? Like so that the compiler, the Python interpreter doesn't explain and I can run everything. What will be the easiest thing to say here? Yes, the number's prime, right? Or just no, like who cares what the number is? I'll just say, sure, I'm wrong. Okay. But why not, right? Return false. Odds are it isn't prime. Why bother checking? Right? I'll call this a stub. It's not right, but it allows me to check the rest of my code. Okay? I might be interested in finding out what happens when a number isn't prime, and I don't want to sit here and try to think of an unprimed number. Why don't I just say return false here? So let's run our code. Now our code can run again. Now I don't have any, I've got green here, right? Everyone's happy. There's a question. It's saying, hey, guess what? You never use it, right? And let me also make the point that the num doesn't have to match the variable. So we can call it with whatever we want. And guess takes on the value of num here. Do we understand? That's from kind of MATLAB functions and stuff like that, right?
So is the parentheses TM doing anything in that line 5?
Oh, it's a trademark because it's important that I maintain intellectual property for my game. Yeah, sorry, that's a good question. Just me being goofy. All right. Okay, so let's run this now. Enter your number, and what number do we want to see? It really doesn't matter, right? 99. Oh, man. Even my simple program, I have an error. All right. I have a problem here. I can click on this. Line 12. In my format, a number is required, not a str. Right? Very confusing, yeah? Let's see, Riku, what do you think?
Is it because like you have to include guess in like the whatever what they're called?
Quotes?
Quotes, thank you.
Well, yeah, so there's something going on here. I think the particular problem is that the type is wrong. %d, of course, is a number, and I think that I'm giving it a number, but somehow I'm giving it a string.
Input automatically formats it as a string, so you need to declare int and then whatever you got out of your input.
Yeah, okay, so great. Paul, that's the right answer. But let's pretend like we're just totally stumped. I mean, I know you guys all know this and you're playing along here, which is great. You're doing the right thing. But for me, for my sake, let's just pretend I am, staring at this code and getting frustrated, right? Rather than just bailing on the system and then sending, somebody, hey, it's printing red, man. Like, let's get out of here. The whole thing's a bust. Stop, right? Pause your program at the troublesome point and look at it. See if you can poke around, right? Wouldn't it be great right before the whole thing falls apart? It wouldn't be great to freeze frame and then be able to kind of peer around and look and go, oh, there it is, right? So let's try that, right? Let's press play here, and you see it's going to ask me to enter a number, so I'll say 45, and then it's going to pause right here. And you see when I hover my cursor over guess, what data type is that? Str. It's not an integer. It is the character, it is the letter 4 and the letter 5. It's really important to understand that the keyboard returns letters. They might look to you like a number, but they're just a squiggle. It's just a symbol. Okay? And depending, and you know, kind of more abstract, right? Depending on your base, that could be a very different actual quantity, right? If 45 in decimal is different than 45 in hex, right? Or 45 in octal. Right? So we need to tell Python how to convert these letters into a numeric value. Does that make sense? And that's what the problem is here. So I can try that out, right? Okay, so here's guess. And if I type guess here, sorry, I've got very little room with my large font and everything else, but you won't have this issue. Notice the quotes around 45. That indicates to me that it's a string data type. Okay? And you can, again, confirm that by saying, what is guess plus 4? That should be 49, right? Instead, you get a problem. All right, so to convert it into a numeric type, we'll use int guess, and then we get 45 without the ticks. And we can confirm that's indeed correct by saying int guess plus 4, and you get 49. Okay? So how can I fix this program? See, Davis, what do you think?
So say again, sir?
Well, so this program has a problem that my guess, I want it to be numeric because I've got to test whether it's prime, and I only know how to measure the primeness of integers. I don't have the thought of like, is a banana prime, right? So I need to convert the text that the user typed into a number. And I found, yeah.
I know at least there's a way to convert like numbers to strings. Is there a function that converts strings to numbers?
Sure. So you see right here in the console.
Oh, yeah. So I would say like if trying to think how it would work.
Let's see if someone want to help him out. Maria.
Sir, could you put int in front of input after guess? Guess equals int of input.
Yes, and that would be, I think, our final solution. But let's unpack that a little bit. The problem here is guess string. That let's make that explicit. The thing I'm getting out of input is a string. If I want to get guessed number, that would be int of guess string. You see? Right? And so, you know, part of it, you know, there's pros and cons to these languages. Python and other interpreted languages allows you to kind of shoot yourself in the foot pretty easily because they're not strongly typed. Nowhere do I tell Python that I expect guess to be a number. Whereas in C, you say int guess, and the compiler will immediately throw a flag up if you try to put a string value into that variable. Python will be like, oh, that's interesting. I guess it's a string today. Okay? So this is making it explicit. And now I can stop and rerun this thing, and I'll put in 7 and, oh, sorry, 7's not prime, and of course that's because my silly function just returns false all the time. Okay? Let's make this a little more compact to Maria's suggestion. I can, just like I can make the outputs of function a little bit more compact by just placing the called function inside, you know, another parameter, I can do something similarly compact to the inputs to a function. So say that rather than guess string here, why don't I just put this other function inside of here? You see that? And again, by the rule of parentheses, this gets evaluated first. That turns into a string. That string then is the input to the integer function, which then finally produces the guess number. right? You can always be more explicit. The only downside then is the number of lines of code that you write, and the need to make up a bunch of different variable names. Does this make sense? Okay. And you see how this stub allows me to focus on these problems first? And so that by the time I'm actually writing my is prime code, I can just focus on whether or not the thing is prime and not worry about funny things about the guess being not numeric. So there's a strong tendency to just get it all done, like type, and then press play. And as you can see already, that's rarely going to work. Right? Once you get really good at it, fine. But for now, just type. If you've typed more than 4 lines of code without clicking play, you've done something wrong. Okay? All right, so I've already got, the last thing I want to talk about here is this silliness with, and this is a small point, but it brings up a nice thing about function parameters. Enter your number. Look how 45 is on the next line. That's kind of annoying. And it's designed to be a convenience feature. In C, I don't know if you remember, but in printf, we always had to end our printfs with what? To go to the next line. Do you remember it's a 2-character sequence to drop to the next line.
Backslash n.
Yeah, the slash n, and like it was part of what made C, just a mean little beast. That you had to add slash n and semicolons and all this stuff. As an instructor, it was great. I had this great way to take off all these points. But in Python, the goal is to make the default simple, right, and the complex possible. Right, so there's this thing called the Zen of Python, and I think if you say import Zen or something, it gives you this poem that talks about Python. I can send you the link there, but that's the idea. So the default, generally when you say print, you want to go to the next line. Okay, so Python's going to put a slash in there for you. In some cases, I don't want that. And so the complex, this weird case, should be possible. So what I can do is specify an extra optional parameter to print. There's a default value already that says drop a new line. But I could say end equals, okay, and then I can put anything I want here. This is the default, end the line with a slash n. If I don't want to end line with anything, I could put nothing here. Maybe I can do this, right? Maybe I can, like that. You see? All it's doing is saying I want to change the end. And so now let's see. You see how I'm typing on the same line? So this is how we specify optional parameters in Python. We'll name them and we'll give them a value. MATLAB also has optional parameters. Maybe you're familiar with functions like max, that you can give it multiple things, or other more complex functions if you're in like robotics. MATLAB's default parameter structure is a total mess. And so it's never clear like what the roles of the parameters are. So in Python, we actually will say, hey, I'm setting this parameter here, and I'm setting it equal to another value that's not the default. Okay, it's more typical to do this and just say, I don't want to put anything at the end. Okay, sorry, 45 is not prime. If I want to try the other branch of the logic, right, if I want to test the other side of this and see did I make a syntax error here? Right? Why don't I just change my stub to return true, and then I can be sure now that that this has been tested. Okay, lines 5 through 12, no problems, right? We got it? You see how we're testing our code? Right, so my goal here, I'm hoping that on your own, you can learn the syntax of Python. Right, knowing some knowledge of MATLAB and other pieces, right? This isn't too different, and you got the book. My goal in class is to give you some insight into why the language is designed the way it is, and also how to think like a programmer, right? Rather than like a student trying to do a homework assignment. or just trying to get it done. So I know this is a small program and you could probably write it all by yourself in one go, but this is the right way to write code. And only now do we go in and actually deal with figuring out whether something's prime. Okay? So,
Sir, I got a quick question about the
yeah.
def. That's like the function in Python, right?
Define, yeah. That's kind of how that's a syntax for declaring a function.
Okay, so you're trying to make, so you're making a function called isPrime.
Yeah.
And then I'm kind of confused, like, in C, like you had to say like, okay, this is the function, and then like end the function, and then there's the main. It kind of seems like your function just kind of goes into later when you reference the function into this if statement. Is there like an end to them, or you just kind of keep
Yeah,
going?
yeah, there is. So first, let's give it a little bit more of a body here. So we can just say, I don't know. This is this is a silly thing. Or maybe we could say here's something more Pythonic, right? If it still won't be correct, but if num and I am just trying to do as little work as possible for my boss. I'm thinking like the boss will get tired after guessing the first 11 primes. And so if the number happens to be in this list, I say yes, it's prime. Otherwise, I say it's false. And I'm just trying to get away with as little work as possible, right? Because I'm really trying to avoid the generic case of finding primes. You should appreciate this, right? We need to. And so there's a bit of a Pythonic thing in here that's kind of clever, right? So, Greg, to your question, how do I know when this function's done and this code starts? There's no end, right? There's no closing squirrely brace, right? So what's the story? How does the Python interpreter know that this is the end of isPrime? Because this P is lined up with the left margin. So it's all about white space.
Oh, okay. Thanks, sir. Forgot about that.
It's all about white space. And so, again, the return true is indented not once, but twice. Because it is part of the function and also part of this if clause. Right? This is after the if else. But Python, man, PyCharm is so clever, right? It can go through, look on both sides of your if else statement, say both of these end in a return statement. There's no way to go to line 6. Right? This code is unreachable. And so all of these, whenever you see a warning sign, take it seriously. Like, look at it. It's tempting just to be like, yeah, grammar checkers. But PyCharm often has your best interests at heart. Okay? All right, so let's just ignore the problem of finding primes. I like to do that in 200, and it gives other students the willies, to go through prime algorithm, talk about, one nice thing about an isPrime function is we can write it once and it's kind of a kludge. And then we can go, ooh, you know what? There's actually more clever algorithms and you can run them faster. And so that shows us that functions encapsulate code and makes it more modular. So that way, later when Marco comes to me and goes, sir, that while loop you had is the slowest thing ever for large prime numbers. There's this message called like Euler's sieve, right? And we can go much faster. And I say, great, if you write that and have the same number of inputs and same number of outputs, I can just plug yours in and have mine work better. Right? So functions allow us to distribute work nicely between members of a team. It allows me to upgrade my code nicely as long as the inputs and outputs stay the same. Okay? But let's not worry about making sure the number's prime. I have other things to talk about. All right, so feel free to Google it, and you can find some awesome things, right? You can also, there's built-ins, like there's Python libraries that do this very efficiently for us too. I want to go back and again, I'm stressing that thinking like a programmer. Okay, I want to read your program like I read a book. All right, a book doesn't start with chapter 6 and then go back to chapter 1. Right? The book starts with chapter 1. And here, this is kind of like chapter 6. If I start reading your program and all of a sudden I drop into this mathematical gibberish of finding prime numbers, I'm like, where are we, right? I'm in the middle of the plot. I'm confused. Okay? What I want to see is this. This is chapter 1 here, right? This is, hello, welcome to Prime Checker, trademark. You know, enter your number. It makes sense. And only if I'm interested in is prime should I ever even be confronted with it. There is, you know, it's a good chance that as a reader of your program, someone goes, oh, is prime, that's a well-named function. I assume it checks if the number's prime. Right? Maybe I want to read about that code, but maybe not. So really, the right spot for this function is below this code. You see that? Then it reads like a book. Welcome to my code. Okay? I read through it top to bottom, and if you're curious about implementation details, see below. See Appendix B for the definition of is prime. Does it make sense? Give me a thumbs up if that kind of theory. All right. Now the problem here is that it doesn't work. Right? That's a great thought, but the computer doesn't think like a human where it can go, oh, let me bookmark my spot and go here and find this. Right? It needs to know what this means before this code executes. Okay? And so here's the solution. What I'm going to do is put this code into a function itself. I said at the beginning, I don't like naked code, and this is naked code. All right? I'm going to start my story, and I indicate to the reader that this is the story by calling it main. It could be called anything you want, but by convention, we'll say the big one is main, right? And this is what I want to run. Okay? And by defining it as a function, the interpreter is going to go through it, right? And the first thing the Python interpreter does is build out all the defines. It goes, oh, okay, here are things that have been defined. Main is a thing. It can run. Is prime, that's another thing, and it can also run. So when I press play, beautiful. Nothing happens. Why not? Have I told the interpreter to do anything, or have I just
Call main.
Yeah, I gotta call main, right? So I've defined these glorious things. I have the capability of checking prime numbers. I have the capability of doing whatever main does, but I never actually do any of it. Okay? So at the very bottom, we're just simply gonna call main. Okay? And the reason why I do this kind of funny structure is in order to make my program legible. So that as I read from the top of the document, remember, this program is small by design. I want it to fit on one screen. But a lot of your programs are going to not fit on one screen. And you want to be able to read them in a logical order. And so by putting the code that you want to run inside of a function, you can say to the interpreter, hey, this is defined, and by the time you actually run main, then it gets down to line 17 here. By that time, is prime has been read in and is usable, so that when you run main, is prime is available to you. Okay? What do we think? This is kind of a Python idiom, right? Idioms are ways that a language is used. So the syntax are the rules of the language. And the idiom is how a native speaker uses the language, right? And so in a lot of code, now I don't know that the author of this textbook does the best job following Python idioms, but this is how we'll write code. There's actually an additional kind of clause you'll see in a lot of code, but I'm not going to put that in here just to make it more streamlined. But now my code runs. Okay, sorry, it's not prime. My code is readable. I've tested my code while I've built it. Right? Things are good. All right. The last point I want to make in the final 4 minutes here is that if I was going to do the implementation of is prime, if I was going to do that, it would be nice not to have to type in a bunch of numbers and see if it's right. Since I've put this in a main function, I can comment that out and just say is prime 43. Right? And if I get the result that it's prime, then I say, oh, great. And if I don't, then it's bad. I'm pretty sure 43 is prime. Okay. But you see here how I'm testing is prime without using any code in the main. Again, thinking like a programmer here. I want to break my task into small nuggets, and I want to beat the bugs out of the nuggets, right? And then only once each nugget is done and tested, then I put them together. Okay, so think in small chunks, execute that chunk, see if you can think of a way to test that chunk in isolation. And then put the chunks together. Right, so a mantra of mine, right, think like a programmer, right? We're going to try to use the right idioms here and do more than just write simple one-off programs in this class. Okay, so as our programs are more complex, these techniques are going to play a bigger and bigger role. All right, so that's all I've got today. Thanks for hanging with me. I know learning a language is tedious. Using it's much more fun, but we're getting there. So your homework for the weekend is to continue through the book. And by this next lab period, I'll give you a in-class assessment, little quiz thing where you're going to modify Hangman. Okay, we'll do that at the end of next week's lab. Okay, so I'll put that in the Google Classroom as well. Expect it to take about 30 minutes maybe for you to do something to it. So with that motivation, bring your questions to class and lecture and everything like that. Okay. Anything else? Okay, and after that, we'll start Battleship, and you'll actually see some graphics on your screen, and we'll actually be doing real stuff here, so that'll be good. Okay, thanks for hanging with me again for the wiring up this whole thing that was last week, and learning a language is tedious, but pretty soon it'll start to be pretty cool. I'm sure. If it's not already, I mean, some of this is pretty fun. Riki's got a smile. Good. All right. Well, that's all I've got. Have a great day, and email me your questions if you have any problems.
Thank you, sir.
All right.
Thank you, sir.
Quick back up I tried to
Thanks, sir.
Yep.
is prime thing. Could you just look at this because I don't really understand this.
Yeah.
It's not too big. It's not like catastrophic, but
Okay. Yeah. Of course. Show it to me.
host disabled participant screen share.
Oh yeah.
So I'm kind of concerned that it says name. Okay, so P can't. I'm sure this isn't the most efficient way to do this, but why is it saying P can be undefined?
Yeah. So there's a path through your code. Now PyCharm isn't quite. PyCharm is very clever. It's not as clever as you are, right? But imagine there's a loop here on line 3. You've got a loop for x in range, right? Now what if range happened to be 0? Like there was nothing in that list, and that for loop never executed. So PyCharm, now you can read that range statement and say, no, I guarantee you line 4, 5, 6, they'll all be executed. And so P will equal something. Right? And so this code actually doesn't, where do you have P equals? Well, yeah, actually you have caused a problem here. Yeah. Right? Because num minus 1.
Awesome. Okay. Thank you, sir. I could not figure out what was going on with it. So thank you.
Yeah. Paul, what's up?
I was just hoping to do a quick little chat about the problem statement. Sorry for getting that to you so late last night.
Uh-huh. Yeah, you sent me. Let's see.
We were trying to avoid being specific because Rigel's definitely got some plans for the bus.